Today's discussion is about linear time invariant system. It is shortly named as LTI system. So these systems are fundamental in signal processing. And Z transform shall be applied for providing a convenient framework for analyzing the discrete time signals and systems. So any algebraic or a difference equation can be converted in the form of Z transform for easy analysis. So Z transform overview. Z transform represents the signals in the Z domain, and also it captures the time domain behavior of signals and systems. X of Z is equal to summation n is equal to minus infinite to plus infinite x of n Z bar minus n. This is the mathematical formula to find the Z transform of any kind of signal. Properties of Z transform. The major properties of Z transform are linearity, time shifting, scaling in Z domain, convolution property and differentiation in time domain. So all these properties decides the response or the outcome of any time shifting or scaling and the multiplicatives of two signals, the convolution behavior and how the differentiation is applied in Z transform. All these are explained in the properties of Z transform. LTI system characterization, how this can be characterized. It is particularly characterized as system response. System response involves both impulse response and output. Impulse response is nothing but h of n. Otherwise, it can be represented as del of n. Here in LTI system characterization, almost during the equation analysis, the impulse response is quite often represented as h of n. Output is given as y of n. Therefore, the output y of z is equal to a convolution of the Z transform of impulse response and input signal. Then transfer function, it is h of z, which is the ratio of output by the input, y of z by x of z. Poles and zeros. Poles are the values of z where the system function h of z becomes infinite, and zeros are the values of the z where h of z or system function becomes 0. It is important to determine the stability of the given function, and the zeros influence the system's frequency response. One important topic in Z transform is ROC. It is the region of convergence, means the range of values over which the x of Z converges. ROC and stability. For a causal system, ROC lies outside the outermost pole. For a stable system, the ROC must include the unit circle. So the ROC is not simply a parameter, it decides the stability and causality of a system. System analysis in Z domain. So the analysis means the two things are being analyzed for any system in Z domain, stability and causality. If all the poles lies inside the unit circle, then the system is termed as a stable system. And if the ROC include the unit circle, then the system is named as causality, where R is the radius of the outermost pole. Some example for Z transform of a signal. So consider a signal x of n is equal to 0.5 bar n u of n. The Z transform is nothing but 1 by 1 minus a, means 1 by 1 minus 0.5 Z inverse. So next is another example for LTI system analysis. Consider system equation y of n minus 0.8 y of n minus 1 equal to x of n. Here y of n is the output, x of n is the input, 0.8 is the coefficient and y of n minus 1 is the delayed sample. So we have to find h of is a transfer function. We have to plot poles and zeros and also analyze the stability and causality of the given system. So let us see how we can perform this operation. So first, apply the z transform of the entire equation and find h of z. H of z will be 1 by 1 minus 0.8 z inverse. So the zeros, there are no zeros, so z is equal to 0 and poles lie at z equal to 0.8. So the major applications, it is used for processing any kind of signal processing, control systems and communication system. In signal processing, it is particularly useful for designing any kind of filter and analyzing any kind of spectrum. Control systems for analyzing stability of any control system and the feedback design, and in communication to design equalizer and channel modeling. So these are the major applications. And stability analysis. So this Z transform is a major used for analyzing any stability, analyzing a function whether it is stable or unstable based on the presence of zeros and ones. Hope you understood this session. Thank you.